Thank you everyone for joining. Today is going to be a little bit special and a little bit different. Joining me today, I have Mark Circle. He is the VP of Engineering for Nexus 3. Mark, how's it going?
Good. Hi, Alex.
Awesome. Okay, yeah. So you guys are probably wondering why Mark is joining us today. So Nexus 3 is actually a KETIV customer. They use a handful of products of Autodesk products. Among them is going to be Revit and Fusion 360. If you're familiar with both softwares, you're probably wondering how are these two tools related, or how do they interact with one another? I'm actually going to go ahead and let Mark kind of introduce himself, introduce the company here in just a second. But an interesting workflow that they've been sharing with us, and that we've seen them kind of develop throughout these last couple of years or a couple months as well, is them using Revit and Fusion 360 to print these scalable models using additive manufacturing. So again, we thought that was an interesting story. We thought that was an interesting workflow, and we wanted to let them kind of talk a little bit about what they do, how they're helping their customers, and kind of the cherry on the top here as well is sharing with all of our viewers, all of our users, the workflows that they're using. Right. So again, if you guys are doing 3D printing at the moment, if you guys are using Revit or Fusion 360, this is going to be a great topic for you guys to really start investing in and start kind of seeing how these two softwares can interact with one another. Like I mentioned, again, we're going to have both Revit and Fusion 360 users. I understand that there's going to be a lot of Revit users watching us today that might not be familiar with Fusion 360 or the way that it handles some of the models. So I do want to make sure that everyone's on a level playing field for today's webinar. I will be talking a little bit about how do you import these models, how does Fusion 360 handle some of this data, and then how can you manipulate it? Right? Because again, sometimes you are going to get some translation issues. Something might get lost along the way. How do you make those modifications to get those models back exactly how you expect them to be? So we'll talk a little bit about that. I'll then hand it over to Mark. He'll explain, like I said, he'll introduce himself. He'll talk a little bit about what Nexus 3 does day in, day out. And then he's actually going to be doing the technical demonstration for everyone as well. So we're really excited to have him on board here for today. And again, really thankful that he was able to take some time out of his busy schedule and be able to share with all of the community here what they do at Nexus 3. So without further ado, let's go ahead and jump in right into the PowerPoint. Like I said, I have a few slides myself. The biggest portion for making sure that you can 3D print a model inside of Fusion 360 or with Fusion 360 is making sure that you import the model correctly to begin with, right? That's going to be really the main foundation to ensuring that you have a correct model to begin with. So the number one thing that I like to always pinpoint is making sure that the file type that you're going to be working with is compatible with Fusion 360. Right? You guys won't believe how many times I get a question asking, hey, can I import this file? And it's a CAM file, or it's a toolpath file for a specific 3D printer. I'll go ahead and kind of show a little bit about what file types you can import into Fusion. But again, you have to make sure that you get the correct import file into the software itself. Step number 2 is making sure that you upload to the correct folder. Again, a little bit redundant here, a little bit kind of self-explanatory, but over the last couple months, over the last couple years, Fusion 360 has somewhat changed a little bit the way that it's handling the new subscriptions or the new users. There's Fusion Teams, and then you have your personal subscription as well. So that can get a little complicated. I'll make sure to highlight that workflow or that those different file types to begin with, just to make sure, again, everyone is familiar with the correct upload location. And then lastly, you want to make sure that you modify and you prep your models so that they're ready for use. Now, again, it's not going to be an everyday thing that when you upload a model, you're going to have to make modifications to it, right? So again, 99% of the time, the models that you import are going to be good right off the bat. but there are going to be specific cases where you import, let's say, maybe an IGES file, which comes as specific surfaces. Maybe it's missing a surface. Maybe you need to do some extensions. Maybe you need to do some trimming. We'll make sure that we highlight this as well in today's presentation. So to start things off here, what kind of file types can you import into Fusion 360? These are the different file types that work with the software, right? So you get quite a bit. So if you guys take a look, you have your traditional step files, your SAT files, parasolids, IGES. I call them IGES if you've seen some of my CAM videos, because again, it imports surfaces, and sometimes those surfaces are kind of up in the air if they get imported or not. So whenever possible, I do try to stay away from the IGES files here. But you also have CATIA files, Autodesk Inventor files, obviously DWG and Autodesk Alias, right? So you do get a handful of softwares that you can import into the software. Like I said, if you're going to being that we're talking about 3D printing, a common question that I've gotten is, can you import toolpath files? The answer is no. So again, Fusion 360 can't read the toolpath, and then it can't create essentially a model from the toolpaths that you have generated. So just keep that in mind as we're moving forward. You have to import some sort of a solid, some sort of a surface bodies in order for the software to actually be able to 3D print that at the end there. Now, I mentioned a little bit about the file location and making sure that you upload your files to the correct location. If you take a look, and this should be the most up-to-date interface that we have inside of Fusion 360. I took this screenshot yesterday. So if you hit your name, the dropdown, they did change where this is located now. So this used to be on the right-hand side. But for those of you guys that are familiar with Fusion 360, you have what you call Fusion Team, right? So if you're a part of a company, of a larger company, and you have to make sure that you give the correct security settings to the correct people, or the correct access to the correct teams, the Fusion Team is going to be the way to go, right? Because you don't want to start intermixing teams. You don't want to give the incorrect access to, let's say, a vendor. So Fusion Team allows you to set those security settings. It allows you to set the correct access to the correct people. And so that's typically where you want to store your data, right? If, again, you're just working with a single license, or maybe you're going to be the only user at the company that's using Fusion 360, then using the single user storage is more than okay, right? But again, if you're a part of a large company and you have multiple people using Fusion 360, you have to be careful, and you have to make sure that you set up a Fusion team, because again, if your colleague leaves, or if you're going to be the admin for the specific team and a user, Fusion 360 user leaves your company, and they've been working inside of the single storage, well, guess what? Now they're taking all of that data with them. So again, we'll talk a little bit about this. We have actually tons of videos, tons of webinars that are already highlighting setting up your Fusion team and kind of highlighting the difference between the team and your single user storage. But again, for those of you that aren't familiar with Fusion 360, you guys are coming from the Revit side of things, Fusion 360 is your CAD software, right? And it's a little bit different because, again, we'll kind of highlight this here in just a second, but it's not only CAD software, it has CAM capabilities. It has FEA capabilities. So it's the way that I like to think of it. It's an all-in-one platform that encompasses the design and manufacturing workflows that your everyday engineer or your designer is going to need. Right. So again, it is going to be a little bit different than some of your more traditional CAD software, because not only does it have all these different platforms or all these different workspaces, it's also going to be cloud-based. Right. So again, a lot of upsides to being a cloud-based software. One of them is the ease of collaboration. The other one is you can access your data from anywhere. And like we're going to show today, you can start working with different file types, right? You're not just limited to one file type from the get-go. So with that being said, once you import the model to the correct location, you also have to make sure that you prepare your model, right? So like I said, 99% of the time, your model is going to be good to go. But there are going to be certain cases where you do want to make a few modifications to the model. Now, this isn't the full breadth of what Fusion 360 can do in terms of model preparation, right? So these are just some of the most common ones that that I'm familiar with, that I use day in, day out. And in talking to Mark, these are also some of the more familiar options that he tends to use to prepare his models. Right, so you have direct edit modeling, you have boundary fill, scaling, shell model, using planes to do a split face or split body operation. Right, so that's a pretty common technique to use. If I take a look at direct edit modeling, right, this is what takes place. So again, with Fusion 360, you get what we call AnyCAD technology or AnyCAD capabilities. I just showed you guys the different file types that you can import into the software. Really, with majority of the file types that get imported, you can do what you see inside of this video, right? You don't need any of the design history. You don't need the sketches, the extrusions, the holes, any of the features that come with it. You automatically can select geometry and you can make modifications to it relatively quickly, right? So again, a little bit different than some of your more traditional CAD softwares in the sense that it lets you modify this data without the need of having the history that was needed in order to create that model. The next one that we're talking about is going to be boundary fill. This one's a little bit unique in the sense that if you take a look at what we have here, we have essentially a series of surfaces, right? So if you take a look at some of these gray sections, these are going to be surfaces that were either imported or created by the user. Now, what boundary fill does, and it's a very unique operation here, but it takes a look at the surfaces, and based off of the surfaces that the user created or that got imported, it's going to automatically find the volume that's enclosed, right? So based off of the cap surfaces, so we have these surfaces that are kind of serving as boundaries. They cap the top and the bottom. Based off of that volume that it found on the inside, it's able to automatically generate a solid body. Right now, this is extremely helpful if, let's say, a vendor sends you just a model, right? And typically, with some of the vendors that I've worked with in the past, they don't like to send you the actual 3D solid, right? They like to send you either surfaces or some sort of a file type similar to that, maybe even STLs in some cases. But if they send you surfaces, a good way that you can, a good technique that you can use is going to be the boundary fill operation, right? Obviously, you can also do some surfacing strategies. You can make sure that you have a watertight seal and then stitch up these surfaces, and then that's going to create a solid body. So many different ways to go about it. But again, boundary fill is one of those useful techniques that's just good to know and good to be familiar with. All right, and then the last one that we mentioned is going to be the split body, right? So it's exactly what it's referring to. It's you're selecting a surface, and then you're going to be splitting a specific body. Now, what this allows you to do is it allows you to create the exact geometry that you want without necessarily having to create reference sketches, right? So what you could have done here is you could have created an outline of the ID there, the inner profile, and then done a revolve cut. Right? But why do that when you can just take advantage of a surface that's already there? Split the body and then remove the body that's not needed moving forward. Right, so many different ways. Again, reason why I'm highlighting this is because Mark himself actually uses a lot of these techniques. And like I said, I know I have a lot of Revit viewers for today, so I just want to make sure everyone's familiar with Fusion 360's capabilities and some of the techniques that Mark is going to be reviewing today. And like I said, so from Revit, actually, I probably missed that, but if you're coming from the Revit side and this is something that you are interested in, or really any other software that you're coming from, Mark, I believe you're exporting from Revit as an SAT file, correct?
Yeah, that's correct.
Okay, yeah, so many different options, right? So you can do SAT, you can do step files. Like I said, it really depends on what software you're coming from. Most of the softwares out there do give you it does give you the option to select a specific file type. So it is going to take a little bit of trial if you're not as familiar with the software that you're coming from, just to see which one of these file types gives you the best outcome, right? So obviously, if you're coming from from Pro E, then you're only limited to some of these file types here. But again, if you're coming from something like Revit, maybe SAT, maybe step file is going to give you the best the best outcome. It's just a matter of making sure that you test that out. All right, so what are some of the benefits to actually preparing these models? Right, so the first and foremost benefit to this is that it removes all the noise from the actual model that you're trying to work with. What I mean by noise is if you've ever taken a look at an import that wasn't correct, you'll see surfaces that are slightly extended, right? Maybe you'll see a little sliver of surface or a little piece that's, out in space. Maybe there's a bolt that's, that's not needed, but it's again, just kind of floating around. You want to make sure that you clean this model up as best as possible. Reason for that is because it really depends on what you're going to be doing downstream, right? So if you're going to be assembling this part, you don't want those little floating pieces all over the place. Of course, you can turn off the visibility of them because they do get imported as separate bodies, but it's just nice to have a nice clean model, right? If you're going to be 3D printing, you have the possibility, or maybe there's a chance that it'll catch one of those pieces and it's actually going to try to 3D print it. So you do have to be careful with with some of these imports. And then probably the most crucial one here for at least for me, because this is one of my favorite topics, is again, Fusion 360 has the CAM capabilities, right? So it does have CAM kind of built into the software itself. And so you want to make sure that the geometry is correct, that you don't have an extra surface, especially if you're going to be creating some sort of a soft jaw around the model to hold or to clamp the part in place. You want to make sure that you don't have any excess geometry that's really just not needed, right? So again, making sure that you have a nice clean model to begin with is going to ensure that you have a nice, in this case, a nice 3D print down the road. Okay, so again, that's kind of just a few steps for importing the models, making sure that you modify the models correctly. I'm going to go ahead and now pass it over to Mark, and he's going to explain a little bit about Nexus 3, what they do, and then he's going to jump into the technical demonstration. So Mark, you ready to share your screen here?
Thanks, Alex.
Okay, yeah.
Nexus3 is an additive manufacturing service bureau, and we're focused on design for additive manufacturing, and we also provide 3D printing services. We help other companies by partnering with them to overcome their traditional manufacturing challenges by using and implementing additive manufacturing. When we first started the company in the beginning of 2020, we were initially focused on assisting the aerospace industry because that's our background. Both Christian and I come from aerospace, but we had some trouble finding business due to COVID-19, and we needed some temporary business elsewhere, along with some affordable software. And that's where KETIV really stepped in and helped us select Fusion 360 as the best design software for us. We used Fusion 360 at first to design and manufacture face shields for a while, and that helped us fill the gap until we got moving. That's kind of our origin story. And then we grew and we grabbed onto Revit, and now we're using Revit and Fusion 360 to clean up models for 3D printing. Okay, so I'm going to jump right over into Revit here now. So here's the Revit model that we're going to be working with today. It's a single-story storage facility. The plan is to only print the outside walls and the doors and the roof. So that's our goal. And then our goal within Revit should be to simplify the model as much as possible. So we want to remove any of the features or instances that we decide we're not going to 3D print in the end. So the more we can clean up in Revit beforehand, the easier our task is going to be in Fusion 360. By cleaning it up, it reduces the number of bodies that are exported into Fusion 360. It reduces the amount of cleanup time that you need to do in Fusion 360. And then depending on your computer system, it can also help make sure that your system stays running quick, because some of these models can actually export 1,000 bodies if you're not careful with it. Okay, so the first step here to do this is we're going to come up to the top.
Yeah, and the whole point behind this too is just making sure that you create or the end goal is to create scalable model, right, Mark? It's to show the customers exactly what they're going to get or what the end result is going to be. We know a lot of people they're actual visual learners, right? So they want to see the end result to kind of get a feel for the overall I guess scope of the project. So that's one of the reasons that some of these customers are reaching out to Mark, is to make sure that they're able to to see exactly what the project is going to look like, and actually get a scaled down size model of the end result here as well.
Okay, so our first task here is again to remove anything we decide we don't want to print. So the best way to do that is to come up to your menu, and you're going to click the View button in Revit, and you're going to come over to the button that says Visibility and Graphics. And what that's going to do, it's going to bring up a separate menu here that lists all the different layers of the model. So you can see there's ceilings, columns, floors, furniture, all these little things that you may not want to bring over into Fusion 360 and you may not want to print in the end. So you're going to want to start going through these and hiding the ones that you don't want to have pulled over into Fusion 360. So I've worked with this model before, so I know it's the doors, the roof, the walls, and the windows that we want to keep. So I'm going to go through these real quick, and I'm going to just hide everything that I don't need to keep. So here's the doors. I want to keep the doors. And I'm going to find the next one, which is the roofs, I believe. Just hiding all these. Here's the roof. So I want to keep the roof. So I'm going to leave that checked. And then just the walls and the windows are left. I'll get rid of all the structural components. There we go. So now we've got the walls and the windows too. So I'm just going to click apply and say OK. And you can see the model has now become significantly more simple. And this is going to reduce the number of bodies that get exported into Fusion 360. Okay, the next thing we want to do is I left all the walls on the unit because I want to keep the outside walls. But one thing that's going to happen is it's going to also leave all the inside walls. And these we don't need because we're only printing the outside, so we want to get rid of these. So what I'm going to do is I'm going to eliminate these inside walls manually, and I'm going to select the two roof pieces and hide them, so it's easier for me to select these inside walls. So I'm going to click on the first one, control click on the second one, so I've got both selected. I'll right click and come into hide and view elements, and it's going to hide those two roof pieces temporarily. And then I'm going to do a right to left selection box, and what that's going to do is it's going to highlight and select all of the features and instances that the box crosses. So I'm going to highlight all these, as many as I can at first. I'm going to right click and I'm going to hide those, hide and view elements. And those are gone. And then I'm going to take and get rid of the rest of these here, right click, hide and view elements. And then we've got all of the interior walls taken care of. One thing we're going to work on when we get into Fusion 360, I want to show you real quick here first. Let me see if I can get a good view. So here's one thing to consider when you're figuring out what to get rid of and what to keep when you merge over into Fusion 360. So the roll-up door here, the instance inside of Revit actually includes the door and the mechanism for the roll-up door. And if I select it, it's going to select both. And I really want to keep the outside doors because that's what I want to move over into Revit, and that's what I want to print. So if I try to get rid of these in Revit, it's going to get rid of the door and that mechanism. But what you'll see when we go over into Fusion 360 is that these mechanisms and the doors actually get separated into separate solid bodies. So it's actually easier to remove the mechanism separate from the door once you get over into Fusion 360. So once you play with this a little bit, you'll start to understand how it transfers over into Fusion 360 and what you should try to clean up within Revit and what you should clean up in Fusion 360 after you've exported. Okay. So the next step is to just get those roof pieces back on here, and then we're set to do the export. So I'm going to come down here at the bottom of your screen. There's this little button. It's a reveal hidden elements. It looks like a light bulb. I'm going to click on that, and it's going to bring up this screen. And again, I'm just going to select and control click on the second roof, so they're both selected. Right click. I'm going to come into unhide in view and elements. And what that's going to do is when I come back down in here to this light bulb and click it again, it's going to bring those two roofs back in, so they're back. So at this point, we've cleaned up the model as much as we can before we export it into Fusion 360. So we're going to come up to File, Export, CAD Formats, and we're going to export it as a ACIS SAT. So the reason for that, we've gone through most of these different file types, trying to export them into Fusion 360, and we found that SAT actually works the best because it exports the features and the instances from within Revit to solid bodies when they get imported into Fusion 360, where the other ones will import them as mesh, which is significantly more difficult to work with when you're trying to modify the model, where if they're imported as bodies, you can use a lot of the standard tools right away to help you edit the model. So you'll want to export it as an SAT file. Okay, so that's it on the Revit side. Let me open Fusion 360. And I have that model already ready to go. So I exported it as an SAT and then pulled it over into Fusion 360, just opened the file right up. And the first thing we want to check once it comes into Fusion 360 is we want to take a look and see if everything got imported as bodies. So sometimes you might find that some of the instances got imported as surfaces. And if that happens, you're going to need to do some more work with those in order to make them watertight solid bodies. If they're surfaces, it's going to be difficult to print, or even they won't print because they're just surfaces and they're not bodies. So looking through this, they've all come over as solid bodies. There's 120 solid bodies, but don't worry too much about that. We're going to quickly consolidate that to just 3 bodies in just a second. The next thing to look at is the document settings in your browser. So you want to take a look at that. Right now it's set in inches, and I'd suggest you can leave it the way it is, but I would suggest that you change the units into millimeters, because most of the slicing softwares for 3D printing, the standard units are millimeters. And what's going to happen is if your units are other than millimeters, if they're inches, you might find that your model imports into the slicer as a really tiny little dot, or it could be imported as some huge file. So if you change the units right now, it's going to save you some time later trying to get that fixed up, and it'll import correctly into the slicer. Okay. So there's that. So the next step now, we've got that set up, is to remove the rest of the unnecessary bodies. And we only had a few left that we couldn't get rid of. Those were those roll-up door mechanisms. So I'm going to show that right here. So you can see now, let me just make sure that my selection tool is selecting body priority. So I'm selecting bodies. Let's make sure. There we go. So now these, you can tell that the doors and the roll-up door mechanisms are now separate bodies. So it's a lot easier to separate them in Fusion 360. So I'll just hit delete on my keyboard on this one, and you can see the door stays and the mechanism is gone. So we're going to clean those up here before we continue.
Yeah, and this really depends on the end result that you're trying to go for as well, right? Is maybe some people would want some of that detail, but you also have to consider the print time that it would take to print that detail, right? So again, it's going to be up to the user. It's going to be up to whoever's going to be printing this, if it really makes sense to print that much detail, or in this case, you know, do you really not need the detail, and all you're really worried about is the outside perimeter of the building.
Yeah, yeah, that's right, Alex. The building here we're working on right now, we're going to make it a single solid model that can be printed for the outside surfaces. At the end of the presentation, I've got a photo of this building too that we also printed with all the interior walls still attached. So you're
Awesome.
right. You need to understand upfront where you want this print to go, what you want to print at the end, so that you make the right decisions in Revit and when you're cleaning it up in Fusion 360, so you don't have to go back. Yeah, you're right. Okay, so I'm gonna highlight these roof pieces real quick. These are I'm gonna talk about a little bit more in just a minute, but for right now, I'm gonna highlight them and I'm just going to rename them so I know which bodies they are. I'm gonna highlight the second one and come over here and rename that as roof 2. So those are renamed, so I know that where they are, and when I need to use them later, we'll come back to them. I'm going to hide those. So again, just like in Revit, it's easier for me to select these interior pieces. And I'm going to do the right to left selection box. Hit delete on my keyboard. I'm just going to get rid of those, and I'm going to try to get the rest of these here and hit delete on my keyboard. So now we've got all those pieces gone. We've got the interior all cleaned up. We've got the exterior walls. And I think we're just about ready to move into working with the roof. Last thing we need to do before we get there is to just combine all those bodies together. So we want to keep the roof separate. I'm going to talk about that in a second. It's a special case. But the rest of the bodies, we can just highlight all of them. Make sure they're all highlighted and selected. And then we're just going to combine them into a single body. So you can do that by coming up to the Modify menu, and you'll click Combine. And you'll see it selected all the bodies. So there's one target body and 64, so a total of 65 bodies it's selected. And what I want to do is join them all together into a single body. So I'll click OK. And there you go. So now we only have 3 bodies to work with. And we've got the one for the walls and the doors, and we got the 2 roof bodies. All right, so I said we would talk about the roof. So the roof is actually always going to cause you trouble. It seems like it's always caused us trouble in all the models that we've worked with. So this one is a little bit of a special case, so we keep it separate and work with it separately. Most of the time, the roof doesn't sit flush on most of the models, and it creates holes that can cause problems in 3D printing. So what we do, you can see here, I'll show you real quick on this model. So on this model, you can see this won't cause you too much of a problem with 3D printing, but it's a little off. It's not quite at the vertex of the walls. It's off a little bit. The 2 roofs don't line up quite right, but there is a hole you can see that's left here. And then there's also a hole on the outside of the wall. You can see that's left over here. So the slope of the roof matches the slope of the outside wall right here. But once it gets to the end, to the outside wall on the side, that's a flat surface, and the wall comes to a point, and then it leaves this hole under here. So what might happen when you do 3D printing with that is you'll have a layer deposited right here, and it might go through a couple layers before it gets to the point where it's going to print this roof. And then when it comes to print that roof, it could be printing a layer in the air. Or you could have, the slicer could say that it wants to print support material here instead of the other material. So what you want to do is get rid of all of those holes. And we found the easiest way to do that, rather than going through and trying to find all of them on the model and hopefully not missing one, is to just remodel the roof. So we're going to go do that right now. It's pretty quick. And we can keep the 2 roof pieces as separate bodies right now, and we can hide them later. We're going to use them as a reference to do the sketch for the roof. All right. So first thing we want to do is we're going to sketch the profile of the roof. So this one we want to sketch from this wall out this direction, because we've got the model is actually 2 lengths. one length on this side of the building, one length on the other. So we're going to split it into two pieces, and we're going to do an extrusion on this side and an extrusion on this side to fix that. So I'm going to come up to my solid body tools, and I'm going to select create sketch, and I'm going to sketch on this side of the building. Let me turn it here. So now we're sketching on this space here. Sorry, one thing I forgot to mention before we do that. I'm gonna skip out of this real quick and go back. I forgot to mention before we do any of the editing to the model. Now is probably a good time to turn on the capture design history. So we've gotten rid of all the elements that we don't want in it, but now we're actually going to edit some of these elements, and we want to capture the design history in case we want to go back and fix it later. So go ahead, Alex.
Yeah, and that's a great point, Mark, too, is by default, when you import a model into Fusion 360, it doesn't capture the design history. For those of you guys that aren't familiar with design history or the way that Fusion 360 works, every single step that you do to create this model, or that you've been doing to create this model, Fusion 360 captures it in what we call it the Fusion 360 timeline. So what that means is if you ever need to go back, if you ever need to modify a sketch, if you ever need to modify a feature, you have that feature being referenced in the timeline, right? And that's, again, being due because you're capturing the design history. So if you don't capture the design history, you no longer have the ability to do that, and that can cause issues down the line. So again, keep that in mind. If you ever decide to import a body or a model into Fusion 360, you do have to capture the design history. By default, Fusion 360 normally does that on native Fusion 360 files, so you don't have to worry about turning that on if you're designing from scratch inside of the software. But if you do import something, you do have to make sure you turn that feature on.
Okay. So to turn that on, we come up to the browser onto the top assembly button, and we come down to the very bottom. We right click on it and we do the capture design history, and that's going to start capturing our history. So you've got the initial model here, the base, and then every edit that we do from here on is going to come up in the history, so we can go backwards if we make a mistake. Okay, so let's go back to the sketch, and we're going to select this plane again. From previous experience working with this model, what we found out too is that where the roof lines up, it doesn't actually line up with the center of the model. So I'm gonna just come over here and show you what I'm talking about. So on this side, you can see that the roof doesn't come all the way to the edge of the building. So it's not really aligned with the center of the building, and where the two roofs meet right now, it's not in the center. And we want to remodel it so that the vertex of the roof is right down the center of the model. So what I need to do with that, so I make sure that I remodel it correctly, is I want to make sure that I project some type of point or some type of reference that's going to allow me to sketch my model with a vertex at that point. So I'm going to go up to the create menu, and I'm going to select project, include project, and I'm going to select this this line right here to project onto my sketch, so I know where the center of the building is. So I'm going to select that and click OK. And now when I come back over to my sketch, you're going to see that line, which represents the center of the building. So that's where I want my center of my roof, the vertex of my roof, to be. So first thing, I'm just going to create a construction line to help me. What I want to do is I just want to create it and make the vertex at the same height as it is originally. So I'm just going to create that there. And when we create the roof, we're not really concerned at this point, since we're filling in the hole inside of the model first before we go in and do any other editing for 3D printing. We're not really concerned with making sure everything lines up. What we want to do is make sure that the extrusion that we create is going to cover all of the holes that could be between the walls and the roof. So we're going to create a pretty good size area that's going to encapsulate all those holes and make sure when we extrude it, they're gone. So first thing we want to do, we're just going to create a line from that point that we created, and let's just move it down to some point in here. So now we've got that line. We're going to make a triangle on both sides. I'm going to click and come over here and attach it to this wall. And I can attach it so it's not horizontal at this point. I'll just click and attach it, and I can come up to my constraints here too. And I'll just click horizontal and vertical, and I'll click on that line, and then it's going to constrain it to a horizontal position. And I'm going to come back with my line tool, and I'm going to create the line on the other side. And again, you don't have to have it perfect. You can click, make sure it's connected to the end of the wall. And on this one, I'll just say that I want it to be collinear with this other line. So now the two are horizontal and they're both the same position. The next step is we want to create the top slope of the roof. So I'm going to go back to my line tool, and I'm going to zoom in here and make sure I grab that point that we created earlier. And let me zoom out, and I'm going to pull that line back over this direction to the edge of the wall. I want it to line up with that wall, and you can see that there's a guide that shows up. Once I've attached my cursor to the edge of the wall and then I pull it up, you can see there's a guide that helps me keep it right in line with it. And the slope at this point doesn't matter. We're going to fix that in just a second. So we've got that all done. Okay, we're going to create a line to the other one, and now we've got an enclosed surface that we can extrude. The last thing we want to do on this side is make sure that the slope's correct. So we're going to click the parallel constraint, and we're going to make it parallel to the original roof. And what that's going to do is just make it so that the slope is the same as the original roof. So now we've got that side completed, and we're going to just finish it and do the same thing on the other side. So I'm going to take my line tool. I'm going to select that point again that we created. I'm going to come over here, make sure that it's on the edge of that wall, click, and that creates that enclosed surface again. And last step is to make sure it's parallel with the original roof. All right. So that takes care of our sketch. We're going to say finish sketch. I'm going to remove the two original roofs, and you'll see we have these two surfaces ready to extrude over to the other side of the building. The last step is to do the extrusion. I'm going to click extrude, click one side. Be careful too, because sometimes it might not capture the entire area that you want to extrude. So you might need to zoom in here, because we had this area enclosed on the roof that we just hid. And so you've got this little area here that didn't get selected when you selected this big area. You want to make sure you select all the areas, and you're going to want to extrude everything from your sketch. The extent, I'm going to select to object, and I'm going to select the other side, this wall, and it's going to extrude it to the other side. Right now it's saying that it's going to cut the building, and that's because the extrusion is intersecting with other surfaces, other bodies, so it's thinking that I want to cut it, but I want to change that to join, so it's going to become a part of the same body as this here. And click OK. All right, so we've got one side of the roof done. I'm going to come back over to sketches, and I'm going to re-show the sketch that I just finished. I'm going to click the extrude button again. I'm going to select that piece as well as this little piece here, make sure we get everything. Distance, I'm going to select to object, and this time I want this roof to go to this wall. And I need to change it from cut to join. Click OK. I'll hide the sketch. And there you go. So now we've created a roof that's eliminated all the little holes that we could have with the model and could cause problems with 3D printing. Okay, so So next step here is to fill in the bottom. So we want to use boundary fill to fill this in. So one thing to note, I'm going to turn on the origin real quick. The model doesn't always come in import directly with the origin of the 360 file. So you need to be careful with that. So I'm not really sure if the bottom surface of this model is aligned with this plane, the origin plane. And I need to make sure that when I do the boundary fill that it's only going to fill to the bottom surface of this model. So what I'm going to do just to make sure is to create a offset plane that's right on the bottom surface of this model. And that's going to create the volume that Alex was talking about earlier. It's going to have the walls of the model, the roof, and then that plane, which is going to create the volume that I'm going to fill in. So I'm going to select construct and click that bottom surface, and the offset distance is 0 because I want it right on that surface, and click OK. And you can kind of see that it's going to create that volume. This is going to enclose this. All right, next step is we need to come up to create and boundary fill. And then we're going to select all the walls, all the surfaces that we want to use to enclose that volume. And we're going to select that plane we just created. And then we're going to select the model here. And Fusion's going to know that you're talking about all the surfaces that are inside here. So when I click that, it's going to say, yep, we found, it turns green. We found the volume that we want to fill. And then I am going to say, yep, I want to fill these. And I'm going to make sure that in the operation from new body, I just want to combine it with the body I already have. So I'm going to select join and hit OK. And just give it a second here. And there you go.
Yeah, and you can also control the infill inside of the preprocessor, right, Mark? Like decide what the infill is going to be, shell thickness and whatnot for this specific print.
Yeah, when you pull it over in the slicer, if you leave this as a solid model, you can actually tell the slicer how much infill that you want as a percentage. So it's not going to use material and completely fill the inside of the model. It'll do some type of pattern that you select and just fill in a portion of it. Okay, so at this point, you've pretty much gotten it almost ready for 3D printing. Now you've got 3 options and you need to decide what you want to do with the 3D print. So you can actually print it as a single solid model with infill, like Alex was just saying. You can select a percentage of infill, so you could export it like this after you've scaled it down, of course. So you'll scale it down to a size where the entire model will fit into the volume of your 3D printer, and you can just print one full model. So that's one option. Another option is you can split the bodies. So you can use a split body tool within Fusion 360 to split it into multiple bodies. And what that's going to do is allow you to make the model a little bit bigger, and you can print it on multiple print beds, right? And you'll have to assemble the parts together. So you could split this into 4 pieces if you wanted to, print them a little bit bigger, and then assemble them at the end. Same thing, you'll have some infill there. Your third option is you can shell the inside of the model and only print the walls on the outside, and I'll show you how to do that in a second. But we've actually done it all of the 3 ways, and the way we prefer is to actually either print it solid like this with infill on on a single volume one print, or split it up into separate bodies and print them all separate, because when you're working with the thin walls and shelling out the models, we found that there's a lot of processing time that happens after you print it. There's a lot of assembly time. It's pretty difficult to put together. Sometimes you can get some warped walls that you either have to reprint or you have to figure out how to fix after it's printed. And we found the most economical way is to eliminate a lot of that assembly time afterwards and just eat it up with the extra print time beforehand and print it with a lower selection of infill, or a lower percentage of infill. So you can do it however you want. Either ways, we've done it all three of those ways, but the best way we feel is to just split it up into separate bodies and print it that way. Okay, so at this point, what we need to do before we do anything else is to scale it down to the size we want. You got to make sure that you do this part of it before you shell it out. If you decide you want to shell it out and you want to just have thin walls around the outside, make sure that you scale it down first, because if you shell it out right now and say that the wall thickness needs to be 1 millimeter, and then you scale it down, the thickness of the wall is going to be scaled down also, and you're going to run into thin walls and then walls that might not even print. So make sure that you do the scaling first, and then you do the shelling afterwards. So let me just scale this down real quick. So we're going to go to Modify, Scale, and we're going to scale down. We're going to select this body, and I'm just going to scale it down to 1/100th of a size. So 0.01, just as an example, and I'm going to hit enter, and you can see it's made it really tiny. So just to get it to fill in the screen again real easy, if you come down to the bottom of your screen here, you can click this fit button, and it'll bring it right back to the center of your screen. Okay, so now we've got it scaled down. So your options at this point, like we talked about, is you can shell it, or you can do a split body. Now with shelling, I'll do both really quick. With shelling, one thing you want to be careful with is detailed features that are on the outside of your model. So I'm going to zoom in here just so you see. This is a door frame, and you can tell with like an actual building, this door frame might only be a depth of an inch or a couple inches. When you scale it down to 1/100th of a size, you can tell that it's going to be quite tiny. And then when you also shell it, Fusion is going to want to shell the entire inside of the part. So you can have problems with it trying to shell small little features like this, which then can cause problems with 3D printing. So I'm going to show you what happens here real quick when that happens. I'm going to come back to the bottom of the model. What I want to do is come up to Modify and Shell. I'm going to select this bottom face that I want to shell out, and then the thickness of the walls. To show you the problem that you're going to run across, I'm just going to make this right now is 0.2 millimeters, but really that's like a single layer thick wall, and you probably want to print it thicker, like at 1 millimeter or so. But we're going to leave it at 0.2 just so I can show you the problem that you could have if you leave these features on the outside of the part. So here's the door frame we were talking about. And now the part's shelled out, and what you're going to see, all the walls are the same thickness, which is great for 3D printing because it's going to keep all the wall cooling down at the same rate, rather than having thick parts and thin parts and having them cool at different rates, and then you wind up with issues with warping. But the problem is with those small features on the outside, it's going to try to shell those out, and you can see that it's shelled out that door frame there. And that can cause a problem with your printing. So the way to get around that is just to, before you do this, is to use split body tools and then create all those, make all these features on the outside, these detailed features as separate bodies, and then go in and shell out the main body, and then you can leave those bodies as separate if you want, or you can rejoin them back to the model. Okay, and the last thing that you could do is do the split body, and that one's fairly simple. So again, you'll come up to Modify, and you can select, you can select Split Body here, and you'll select the body that you want to split, and then you can select the plane that you want to split it at. You can create the plane if you want, or you can select a feature on the model that you want to cut at. So I'm going to select this here, and it shows where I'm going to cut it. Click OK. And there you go. So now I have the two separate bodies that I can print separately.
And this is great if you want to print larger scale models, right, Mark? And then if you just want to build them as sections and then piece them together. I think you mentioned you had a few images of that.
Yeah, I do. Yep. Yep.
Got it. Okay.
There's just one more step here, and then we're finished with the workflow. And I can show you some pictures of how we did some of those. So last step is now you're ready to print. However you decide to set up the model, if it's showing it or splitting it, you can come up to the File menu, click 3D Print, and then you're going to select the body that you want to print, and it's going to show a preview of the mesh. The refinement is how Fusion 360 is going to decide how many triangles it's going to want to put in here. I always use high. I've never had a problem with it with 3D printing at all. And it's going to try to keep as many of the detailed features as possible because it's going to use more triangles and try to maintain or keep those details. And then you can decide to send it to a 3D print utility if you want, like Mesh Mixer, if you want to play with the mesh or do any other cleanup. Otherwise, you can uncheck that and then just click OK, and it's going to export it as an STL, which you can then put into your slicer. Okay, and that's it for the workflow.
Awesome. Yeah, like hopefully we have a few of our viewers here that picked up a thing or two on workflows. So it comes to show, right, that not only do you have to do some cleanup work inside of Fusion 360, but you also have to do a little bit of cleanup work in on the Revit side of things as well. So that goes for any software. Sometimes you are going to need to hide specific components and assemblies, whether you're coming from an actual CAD software to Fusion, or in this case from the Revit side as well. So yeah, no, I want to thank you, Mark. I know this was this is a workflow that you pretty much perfected at this stage. So I do want to thank you for for walking everyone through how to how to do what you do on a day in day out basis. And so yeah, if you want to jump over to the PowerPoint just so we can take a look at some of the images that you've done throughout the years. So yeah, so you do have some multicolor prints as well, right? And some pretty large scale models as well.
Yeah, so this model here that we created, we actually created it just like we said, we shelled it out. That was one of the options. We said we shelled it out and made it into, I think it came out to over 70 pieces that we assembled afterwards and then painted. It's got the window mullions you can see hanging out here that we printed separate. We attached some PETG clear plastic sheet to it to make them look like windows, painted it all up. We've added LED lights in there even.
Wow.
And,
okay.
And use that as a demo model.
That's awesome. Yeah. So like I said, if you guys ever have any questions, and it looks like there's some more models there that you wanted to show.
Yeah. Just real quick, this is the model that we kind of went over today. So this one up here is printed all in one piece. We actually printed the walls all in one piece, and then the roof we printed separately because, like we were talking about earlier, it depends on what you want to print and what you want to show. So we printed the roof separately so it could be removed, and then you could see all the storage units within the building. And then this picture here is one we're making with. We're making it into pieces, so it's 4 pieces. So you can see they're bigger pieces. We split it up into 4 pieces so we can make the model bigger, the final model bigger.
Got it.
Okay.
Awesome. Yeah, no, that's great stuff. And then here's your contact info again if you want to just say some last words here.
Yeah, just real quick. So if you want to get in touch with us, we're located in Glendale, Arizona. Our website is nexus3mfg.com. If you log on to our website, you can contact us from there, or you can also join our newsletter. We'll post blogs every week that have to do with other types of additive manufacturing technologies. If you want to get in touch with me directly, my contact information is there too at mark@nexus3mfg.com.
Awesome stuff. Yeah, thanks again, Mark. Really appreciate all the work that you put into demonstrating this webinar for the viewers. And yeah, I know I follow you guys on LinkedIn as well, so I know that the blog posts you guys post them pretty often. So it's good to see kind of where the additive manufacturing industry is heading, and also kind of some of the work that you guys have been doing for some of the customers. So I think this is a good time for some questions. I think we had just a few comments here from Carl. It looks like he had a few comments on some of the workflows inside of Revit, and he mentions that a quicker way would have been to would be to have all the interior walls on a work set, which then can be turned off. So that's absolutely right. Inside of Revit, you can have different work sets, right? So kind of if you can think of them quote unquote as layers, uh, turn them off, turn them on, and then that just makes things a little bit easier. So yeah, thanks a lot, Carl, for the feedback. And let me just look here if we have any more questions. Give it just a few more seconds. And again, just final thoughts. Thanks everyone for tuning in. Like I said, if this is your first time tuning into a Fusion Friday, I hope you picked up a few things here on the software. Like I said, this is a little bit more of a unique case, being that we had both Revit topics and Fusion 360 topics. But like I mentioned in the beginning, what better way to talk about Fusion 360 than someone that's using it for their business on a day-to-day basis, right? So again, I want to go ahead and thank Mark and the team over there at Nexus for joining us. It doesn't look like there's any more questions. So with that, Mark, thank you again. And thank you everyone for tuning in. And we will see you guys on the next one.